On this video, we're going to look at 4.3.34, and we're specifically going to focus on the trig that's going on here. So the calculus is to find the interval in which the function is increasing and decreasing. So that's going to focus on finding where the derivative is positive or where the derivative is negative. So the calculus part of this is to find the derivative of this function, which would be minus 2 cosine times the derivative of the inside, which would be minus sine. So my function becomes 2 cosine of x times sine of x. I set that equal to 0, and I'm specifically looking on the interval minus pi to pi. So it turns out when is the derivative equal to 0 to find the critical points? So that's going to be when cosine of x equals 0 or when sine of x equals 0. There's a few different ways to do this. You could graph the function. You could graph it from minus sine to sine. And let's say I graphed cosine. I could graph sine here. See if I did that right. Got a little bit further here. So if I kind of put in some reference points, I didn't go all the way here on this side. So it's not, so this point would be at minus pi. This point would be, or this here, minus pi over 2, 0, pi over 2, and pi. So we have cosine and sine, cosine of x here, sine of x in the red. Another way you could look at it is the unit circle. So we have these points on the graph. Here we have the point 1, 0, this is the point 0, 1, this is the point minus 1, minus 1, 0, and this would be 0, minus 1. So the points in which sine equals 0 and the points in which cosine equals 0, either with the x value is 0 or the y value is 0. Cosine equals 0 is going to be at minus pi over 2 and at pi over 2, and the sine is going to be 0 at minus pi 0 in pi. So we're going to have our number line here, and we're going to look at the intervals from minus pi to minus pi over 2 to 0 to pi over 2 to pi. And we're going to test the sign. So from minus pi to pi over 2. Another way to look at it could be from, like, if this is minus pi, this would be minus pi over 2, this would be 0, this would be pi over 2, this would be pi. And if I just kind of go around the unit circle this way, and you might have recalled the terminology, something like all students take calculus, where everything is positive in the first quadrant, only sine and cosecant, only tangent and cotangent, and only cosine and secant are positive in these quadrants. Or you can look at the graph here and see, okay, in this interval, cosine and sine are both negative, and a negative times a negative is a positive. So from minus pi to pi over 2, the derivative overall is positive. From pi over 2 to 0, I have sine is negative and cosine is positive, and negative times a positive is a negative. Or I could look at cosine, that's the fourth quadrant, cosine is positive, but sine is negative. So again, I have that positive times the negative up here, telling me the sine from minus pi over 2 to 0 is negative. From 0 to pi over 2, everything's positive. And then from pi over 2 to pi, sine is positive, but cosine is negative. So positive times a negative. So then that tells me that this function is going to be increasing on the interval from minus pi to pi over 2 and from 0 to pi over 2, and is going to be decreasing on the interval from minus pi over 2 to 0 and from pi over 2 to pi. And that's where these kind of come from. You have to solve where cosine equals 0 and sine equals 0. So you end up with these critical points, and then you have to test the value within these critical points. Hopefully this clears up any questions you have on the trig that goes on here. If you have any other questions, let me know.